So hi everyone. Welcome to our very first talk of the NCU-Delta online talk series. So I'm Yan-Chen Pan, your host tonight. So for those who haven't heard it before, this talk series will be given by, I think, all awardees of NCU-Delta Young Astronomer Lectureship Award. So I think this award is established by the National Central University and the Delta Electronics Foundation to recognize young scholars. I think it's under the age of 45. So, who have made outstanding contributions in the field of astronomy. So each year, this awardee will be invited to Taiwan and to interact with the local astronomers and the public people. So I think the first award was given in 2012, almost 10 years ago. So, so actually the original plan for this year was to hold a big event by inviting all the previous awardees to come back to Taiwan to celebrate. But things has been pretty complicated due to the COVID-19. So we have decided to make everything online, so unfortunately. But the good thing is, so it's more flexible. Maybe we have more people to join this talk, and as long as you have a link. So to be short, so our speaker today is Professor Masaomi Tanaka, from Tohoku University. So it's really our great pleasure to have him here. So I think Masaomi received this award in 2017. Is that correct? Right? Okay, yeah. I think, he has a pretty broad interest in astronomy, particularly in time domain astronomy, such as transient, supernovae, kilonovae. And I think he was also involved in this great discovery of first kilonova in 2017 by, using LIGO-Virgo detection. So for those who don't know, the kilonova is like an electromagnetic counterpart of a binary neutron star merger. And I think this is quite a great achievement and milestone in modern astronomy. So today, his topic, he's going to talk about the multi-messenger astronomy and the origin of the heavy elements in the universe. Okay, so Masaomi, I'll let you take it away. So I think you can share your screen now. Thank you very much. Please.
Okay. Thank you very much, Yan-Chen. And first of all, I'd like to thank the organizer, including Yan-Chen, and also people in NCU, also Delta Electronics Foundation for this opportunity. So I'm really, it's a great pleasure for me to give a talk. And as Yan-Chen introduced, it was even probably better if I could visit you. But thanks to this online environment, I'm also happy to give a talk to many of you. So I'd like to thank the audience for joining today's seminar. So today I'd like to talk about the multi-messenger astronomy, in particular focusing on the advances of our understanding about the origin of a heavy element in the universe. And this talk is very much related to the gravitational wave astronomy as well. And as Yan-Chen introduced, 2017, the first gravitational waves from the neutron star merger have been observed. And I still remember that I visited NCU for this NCU-Delta Award just one day after the press conference of the discovery. So still I cannot forget about this. And I really enjoyed my visit in NCU, and as well as a public talk at the high school. So I hope I have a next opportunity in the near future. So this talk will be roughly divided into these 4 parts. And the first part will be very broad. So I think many of you are familiar with our current understanding about the origin of the element in the universe. But I'd like to start from the very beginning, because that's closely related to today's topic, which is a multi-messenger astronomy and also the origin of heavy elements. And then I will introduce what we learned from the observation of gravitational waves from neutron star mergers. But this was already about 3 years ago or 4 years ago. So I also would like to focus on the what we learned, but what is the remaining issue and what is the future prospect. And I hope you enjoy the last part of this talk. So let's start from the elements, thinking of, about the elements around us. So we are all now breathing. So we are breathing air, absorbing the air. And this air consists of the mainly nitrogen, oxygen, and also argon and neon or small fraction. So unconsciously, we are surrounded by a variety of the chemical elements. Please have a look at your hand, for example. So our body consists of mainly of H2O, water, but also our bone includes carbon, and of course, these our body includes these elements. What about the Earth? The surface of the Earth crust. That's the Earth is a rocky planet, so the main composition is silicon and oxygen, and followed by aluminium, iron, calcium, and so on. So we are surrounded by these elements. However, the big question is at the beginning of the universe, these elements did not exist because at the time of the Big Bang, the beginning of the universe, the only hydrogen, helium, and small amount of lithium existed in our universe. But as you all know, that we are surrounded by a variety of the different elements. So the big question in astronomy and astrophysics is the origin of these elements, where these elements come from, and what kind of astronomical object made these elements. So this is the topic of today's talk. So you know the periodic table, and the hydrogen, helium, and lithium are the first three elements with the least atomic number, smallest atomic number. Then today's topic is the element heavier than the lithium. So where are they from? But actually up to iron, from carbon to iron, we have a really good understanding thanks to the intensive research in the last more than 50 years. And the answer is stars. So these elements were made inside of the star. So this is a brief overview of the life of the entire life of the star. For example, take the massive star as an example. Massive star means the mass of the star is probably greater than 10 times of the sun. Then inside of these stars, the many heavy elements are produced, synthesized, and finally such a star explodes as a supernova, which leaves neutron stars or black hole. So what is happening inside of these stars? So this is a nuclear burning. So you know that our sun, inside of our sun, the hydrogen is converted to helium, which produces energy, nuclear energy, and this is the reason why our sun is so luminous. But when the star exhausts the hydrogen, then for the case of the massive star, the helium is converted to carbon and oxygen, and this kind of nuclear reaction continues up to iron. Of course, the stars are gases, so iron is not metal iron, the solid iron, but the gas iron. But these heavy elements are produced inside of the star. So speaking about the origin of the element from like a carbon, oxygen, up to iron, the main origin is the inside of the star. But if this happens just inside of the star, then we cannot take iron, for example, because iron exists very inside of the star. But iron is the most stable nucleus, and finally star collapses because there is no more nuclear burning after iron, then the star cannot support their own gravity, then star starts to collapse into the center of the star, which causes collapse. And this collapses, the central part of the star collapses, and finally this makes a very strange star, extremely high density, which is called neutron star. Or maybe some cases it becomes a black hole, maybe many of you are familiar with. Then when neutron star is formed inside of the star, massive star, then the outer part of the star bounces at the surface of the neutron star, and finally the outer part of the star explodes, or it expands into the interstellar space. This is called supernova explosion. Although the exact mechanism is still unclear, we observe this phenomena in the observational astronomy. So we know that some stars explode. Then when stars explode, then element produced inside of the star are ejected into the interstellar space. And in the long history of the universe, this kind of stellar evolution and the explosion of the star supernova, and also again, another generation of the star is formed by the gas ejected from the supernova. And again, this process happens in the next generation star, and also next generation star explode as a supernova. So this kind of cycle happens so many times. And finally, our universe has lots of heavy elements. So this is the actual image of the supernova explosion in our galaxy. So this is a famous Cloud Nebula. So speaking about the origin of the element around us, so thanks to the nuclear burning inside of the star, and also the supernova explosion, and finally the element comes to the sun and also the earth, and also this goes to the element around us, like the air and our body and the earth. So far I was talking about the origin of the element up to iron, and this understanding is quite matured, I would say. Of course, there are several kinds of supernova explosion and different masses of the star, but roughly speaking, the element up to iron is thought to be produced by stars and supernova explosion. But as you can see in the periodic table, there are so many other elements heavier than iron. And today's main topic is these heavier elements, including, for example, the famous element is gold or platinum. So the origin of these heavy elements are still not understood. So, which means no one knows the exact answer. So last a few decades, astronomers and astrophysicists have been studying the origin of these elements, like including gold and platinum. And this is very much related to the multi-messenger astronomy. So today I'd like to introduce the recent understanding of these